Hi, welcome back. This is Oceans, Atmosphere, and Climate Lesson 6, Part 4, and I have some helpers with me. This is my family. I'll let them introduce themselves.
Hi, I'm Charlotte.
Hi, I'm Eliza.
And I'm Jacob.
And they're going to help us do the current tank investigation. Okay, so to be successful, you're going to need a couple of things. You'll need to have something to write on, something to write with, someone to talk to, and you can also gather a few materials around your house for this activity, which is a straw. If you don't have a straw, you can tightly roll up a piece of paper and you can use it just like you would a straw. And then you also need ground pepper and then a shallow waterproof container like a baking pan, or we have a rectangular plastic tray. Anything like that would work just great. Scientists use models to learn about the things that they can't observe directly, and so we're going to use this model to learn about prevailing winds. And this is the question that we're trying to answer. What determines how ocean currents move? You read an article about ocean currents and about the Gulf Stream. You did an exploration on the sim, so this is a chance to do an exploration in real life. Okay, so today we're going to be modeling how the prevailing winds around the Earth influence the currents of the ocean. And you'll be creating wind through straws. Show them your straws, you guys. There we go, we've got some straws. And we'll be creating wind through these straws to model the winds around the Earth. So, Jacob, will you tell my students what the parts of the model represent?
Yeah, so the water inside of the bin represents the ocean. The blowing through the straw represents the prevailing winds. The pepper inside of it is to illustrate the moving ocean currents to show movement. And the sides of the tank represent the continents.
So our bin has 4 sides, and that's pretty normal for a bin, unless you're using a circle cake pan, which is actually fine as well. But on our planet, we have continents, and so the walls of the tank just represent the continents. Okay, so as you create your model, you'll have 3 missions that you're trying to complete, and you'll need to record your observations. So a couple of things about safety before we go on. First of all, do not share straws. We don't want to share any bacteria or viruses. And we're just going to have one person at a time. If you're doing this by yourself, that's totally okay. But just notice that if you start to blow through the straw too much, you might start to feel a little bit dizzy. And if that happens, stop blowing, sit down until the feeling goes away, because you can sometimes get a little dizzy if you blow too much through the straw. Okay, so here are the 3 steps to doing this activity. First, we're going to discuss and record our predictions, and you can either draw your predictions on a piece of paper or you can just talk with each other like we're going to do here. And then think about how you could actually complete the mission, and then make a prediction with a drawing about how you think each mission will work. So once you actually discuss your predictions, then move on to the missions. There's 3 altogether, and you're going to do one at a time. And so after you're done with the mission, then discuss it or just write down some of your ideas. Okay, Charlotte, you get to do the first mission. Are you ready? Okay, so in this mission, what we're trying to do is find a way to make the current move in one direction like a gyre. And my students have learned that the word gyre just means an ocean current that moves in a circular path. So that's what we're going to try to do. So the predictions that we drew beforehand, and this is just an example prediction, is that if we blow with wind across the middle of the container, then we could create a current in the shape of a gyre. Okay, so do you want to try that? And then we'll see if we have to adjust our predictions as we go. Okay, Charlotte, let's see if we can make this work. Try to draw, and you want to blow across the surface of the water. Okay. Oh, I see it starting to move. You can see that happening. So you can see a flow. Okay, keep doing that. I'm noticing the water is moving in this direction. When it hits the wall here, it starts to go this way or that way, which is very similar to what we saw in the sim when we were doing that. And then I see it coming down. Do you think that you've created a gyre like this? What do you think, Charlotte? Or does it?
It's kind of going along the
It's
edges.
kind of like going along, like maybe you have almost 2 gyres, huh? Where do you think you should move your straw so that you can just have 1 gyre? Okay, try that. Move it all the way over there. Okay, yeah. Let's give that a go. Okay, now I see the water moving this way. And it's the pepper that we're seeing moving, but the pepper is just moving as the water moves. Oh yeah, look at that. You can see that is a nice gyre forming. Yeah, what do you think, Jacob? Do we have a gyre?
Yeah.
Yeah,
that's another one.
I think so too. Yeah, there's a big gyre here. Okay, all right. That looks great. Let's talk about what we just did. Do you think that we were able to complete this mission?
Yeah.
Yeah, we were. So we could check off yes. And then if yes, describe how. And if no, why not? So when you first started blowing, Charlotte, you blew down the middle and we saw kind of a current forming along the bottom and also one along the top, right?
Yeah.
So then how did you adjust the wind to make it so that you could just get one big giant gyre?
I went on one half side of the tank.
Yeah, so she just moved her straw to here and started blowing there so that it could go all the way around, and we were able to successfully do it. Okay, all right, Eliza, are you ready for mission 2, which is a little bit harder? Let's give it a go. So with mission 2, we need to find a way to make the current move in a direction that's different from mission 1, so not in a gyre. So let's see if we can get an ocean current to form in a way that's not a gyre. And what's your prediction? How do you think you'll need to blow in this tank to get something that's not a gyre?
Blow straight down.
Okay, yeah, let's give it a go. Okay, Eliza, we got this adjusted. Show us your plan of blowing straight down. What seemed to happen when we did that?
It moved away from the middle.
Yeah, it did. It moved away from the middle. Okay, so the thing is, prevailing winds, which the straw and the air represent, only blow across the surface of the ocean, across the surface of the earth. And so your way is a good way to do this, but maybe wouldn't happen in real life.
Yes.
So why don't you try a different way to see if you can complete mission 2? Do we need more pepper? We always need more pepper. Okay, go for it. So you're going down the kind of corner, and what did you see happen there?
The same thing.
Describe
Kind
what
of.
you mean by same thing.
It's like moving in half the pan, like
So
2 gyres.
2 gyres in the pan when we blew across. So it seems like every single time when the current moves, when it hits the wall, or the wall that represents the continent, it starts to kind of move in a gyre form. Okay, all right. That sounds pretty good. Talk about mission 2, and were we able to successfully complete mission 2?
No, not.
No. We would say no. That doesn't mean anything's wrong with you. It just means that it seems like ocean currents in this model like to form gyres, don't they? It hits the wall of the continent, and bends and forms a gyre in our container. Okay, so are you ready for mission 3? This one is really complicated. So we're going to make Jacob do this one. Okay, Jacob, are you ready? Okay,
Yes.
here is mission 3. In mission 3, we have to find a way to make the current move faster than it moved in the previous missions. Okay, let's give it a try. Okay, so Jacob, before we do mission 3, I'll add a little bit more pepper. Tell us your prediction. How do you think you can get this current to move faster than it did in the previous 2 missions?
Well, maybe we could blow faster, but other than that, I think just keeping it as closest to the edge as you can so you can make it move as quickly as you want it.
Okay, so I heard you say 2 things, which is 1, to blow along the edge of the container, and 2, to increase the wind. So to blow harder and faster to make it the wind stronger.
Yeah.
Okay, let's give it a try. Go ahead and see what we can do. Definitely more intense wind. I definitely still see a gyre forming. We're losing some pepper. And what do you 2 girls think? Do you think that we do have a gyre that's moving faster than you guys did?
Yeah.
Yeah, so increasing the speed of the wind seems to increase the current speed as well.
Yes.
Okay, all right. Okay, so we just completed mission 3, and Jacob, tell us about your results. Were you able to complete this mission?
Yeah, it moved faster when you blew faster, so
Okay.
that was good.
So increasing the speed the speed of the wind increases the speed of the current. Okay, we discovered a lot of really cool things today. Thank you for helping me out.
Yeah.
Awesome.
Okay, so we've learned so much in lesson 6. Let's just kind of wrap it up by looking at this picture one more time. Prevailing winds set ocean currents in motion. We can see the white lines here, and they're pushing the ocean currents there. The currents are pushed in the same direction as the wind until they reach the edge of a continent, which causes the currents to change direction and move along the continent. So this is an exciting moment because we've just uncovered another key concept. So this key concept says prevailing winds and the position of continents determine the direction of ocean currents. So if we think back to the beginning of lesson 6, we wondered what could cause currents to change, but we knew that before we could answer that question, we had to first be able to explain what could cause currents to form. So now that we know that, we're ready to start thinking about what could cause an ocean current to change? So I want you to think about that before we go on to lesson 7, where we're going to discover some answers to that question. I just want you to think on your own over the next couple of days before you watch lesson 7. What do you think? What could cause an ocean current to change? Okay, I'll see you next time. Bye.